Hey folks, this is Akash, and let's get started with building Aneka clouds. So, Aneka is a platform for developing distributed applications for cloud. So, as a software platform, it requires infrastructure. So, let's study about its infrastructure organization. So, the diagram represents the Aneka cloud infrastructure overview. So, in this figure, central role is played by the administrative control, which performs all required management operations. Repository is the fundamental element for Aneka cloud deployment. It provides storage for all the libraries required to lay out and install the basic Aneka platform. The management console manages multiple repositories and select the one that best suits the specific deployment. The infrastructure is deployed by harnessing a collection of nodes and installing Aneka Node Manager, which is also called as Aneka Daemon. From infrastructure point of view, all nodes perform uniformly only as long as it has internet connection. So next is logical organization. Logical organization of Aneka Cloud can be very diverse since it strongly depends on the configuration selected. The master node features all services that are mostly likely to be present in one single copy, and that provides the intelligence of Aneka Cloud. One special characteristic of master node is presence of index service or membership catalog. All the scheduling services are maintained in the master node. Here the master node is normally persisted on the RDBMS in order to provide a fault-tolerant infrastructure. The worker nodes constitute the workforce of the Aneka cloud and are generally configured for the execution of applications. Storage nodes are optimized to provide storage support to applications. The number of storage nodes strictly depends on the predicted workload and storage consumption of applications. The figure shows a common deployment for a private Aneka cloud. This deployment is acceptable for a scenario in which the workload of the system is predictable and the local virtual machine manager can easily address access capacity demand. So most of the Aneka nodes are considered of physical nodes with a long lifetime and static configuration and generally do not need to be recognized. Often the different nature of the machine harnessed in the private environment allows for specification policies on resource management and usage that can be accomplished by means of the reservation service. For example, desktop machines that are used during the day for office automation can be exploited outside the standard working hours to execute distributed applications. Workstation clusters might have some specific legacy software that is required for supporting the execution of applications and should be preferred for the execution of applications with a special requirement. Public cloud deployment mode features the installation of Aneka masters and worker nodes over a completely virtualized infrastructure that is hosted on the infrastructure of one or more resource providers such as Amazon EC2 or GoGrid. In this case, it is possible to have a static deployment where nodes are provisioned beforehand and used as tough they were really machines. This deployment merely replicates a classic Aneka installation on a physical infrastructure without any dynamic provisioning capability. More interesting is the use of the elastic features of IaaS providers and the creation of a cloud that is completely dynamic. The hybrid deployment model constitutes the most common deployment of Aneka. The hybrid cloud deployment is a combination of public and private cloud deployment mode. In many cases, there is an existing computing infrastructure that can be leveraged to address the computing needs of the application. This infrastructure will constitute the static deployment of Aneka that can be elastically scaled on demand when additional resources are required. The application model represents the minimum set of APIs that is common to all the programming models for representing and programming distributed applications on top of Aneka. This model is further specialized according to the needs and the particular features of each of the programming models. The figure shows a distributed application running on top of the Aneka is an instance of the application base where M identifies the specific type of application manager used to control the application. Aneka further specializes application into two main categories: the application whose tasks are generated by the user, application whose tasks are generated by the runtime infrastructure. These two categories generally correspond to different application base class and different implementations of the application manager. The first category is the most common and it is used as a reference for several programming models supported by Aneka: the task model, the thread model, and the parameter sweep model. The second category covers the case of MapReduce and all those other scenarios in which the units of work are generated by the runtime infrastructure rather than the user. The figure describes the reference lifecycle of each service instance in the Aneka container. The shaded balloon indicates transient states. The white balloon indicates steady states. A service instance can be initially be the unknown or initialized state, a condition that refers to the creation of the service instance by invoking its constructor during the configuration of the container. Once the container is started, it will iteratively call the start method on each service method. As a result, the service instance is expected to be in a starting state until the startup process is completed, after which it will exhibit the running state. This is the condition where which the service will last as long as the container is active and running. This is the only state in which the service is also able to process messages. If an exception occurs while starting the service, it is expected that the service will fall back to the unknown state, thus signaling an error. When a service is running, it is possible to pause its activity by calling the pause method and resume it by calling continue. From pause state, it moves into the resuming state while restoring its activity to return to running state. When the container shuts down, the stop method is iteratively called on each service running, and services move first into the transient stopping state to reach the final stop state, where all the resources that were initially allocated have been released. Aneka is a pure PaaS implementation and requires virtual or physical hardware to be deployed. Hence, infrastructure management together with facilities for installing logical clouds on such infrastructure is a fundamental feature of Aneka's management layer. So this layer also includes capabilities for managing services and applications running in the Aneka cloud. Platform management. The features available for platform management are mostly concerned with the logical organization and structure of Aneka cloud. Application management. Applications identify the user contribution to the cloud. The management APIs provide administrators with monitoring and profiling features that help them track the usage of resources and relate them to users and applications. This is an important feature in a cloud computing scenario in which users are built for their resource usage.